Hey everybody, this is Ben. Welcome back to my Leetcode series. And today we're going to be looking at problem 1481 called the least number of unique integers after k removals. So the prompt here is pretty simple. We'll run through the prompt. We'll talk about the process of solving and the pseudocode, and then we'll code it up together. So given an array of integers AR and an integer k, find the least number of unique integers after removing k elements. So let's go ahead and just look at an example here. So in this first example, the array given is 5, 5, and 4, and we need to remove one element, or one appearance of an element. So by k, they just mean what number can I grab from this array that I can remove. Okay. So in this case, to get the least number of integers after removing k elements, we just remove 4. Because that means only 5 is left. So there's only one unique integer left if we were to remove 4. Let's go ahead and walk through the pseudocode. We'll talk through another example here. So our objective is to remove k elements in a way that we end up with the least number of unique integers possible. So how can this be done? We need to remove elements of the least frequency first. Then we may be able to remove those elements entirely from our array, which will decrement our end result. For example, with the array 4, 3, 1, 1, 3, 3, 2, which elements should we remove if our k value 3 is given in this example? So first, let's count the frequencies of each element. 4 appears once, 2 appears once, 1 appears twice, and 3 appears 3 times. So we can remove 3 total appearances of any elements. We should start by removing 4, since it only has one appearance. This will remove 4 entirely from our result, meaning the number of unique integers left in our array is 3. And then we need to update our k value, so we'll say k minus 1 equals 2. So next, we can remove 2. It only has one appearance. This will remove 2 entirely from our result, meaning the number of unique integers left in our array is 2, We can update k, so k minus 1 equals 1. We only have one element left to remove. We can remove an appearance of 1 or an appearance of 3, because 1 has 2 appearances, 3 has 3 appearances, without changing our end result. However, let's stick to our same algorithm. So we're going to remove an appearance from the element with the least frequency currently. So the least frequency currently is 2. So we'll just remove one appearance from that. So 1 will now equal 1 appearance. And we'll say k minus 1 equals 0. Since k equals 0, we'll return our result, which is the number of unique elements in the array, after we removed as many appearances as we could of the least frequency elements. So it can be a little confusing, but once we get into the code, I think it makes a lot more sense. So let's look at the pseudocode here. First, we need to think, how can we keep track of frequencies of each element in our array? We can do this very easily using a hash map. We'll just use a for loop to scan through our array, and we'll use the put command to insert the element in the array at index I, and then we'll say getter default element array 0 plus 1 to update the frequency. So this will insert an element into the array. If it's not already present in the hash map, we'll add it in with a value of 1, so key value pair, else its frequency will be incremented by 1. So if the key exists, we'll just update its value by plus 1. Now a hash map cannot be sorted, so we have a bit of a dead end without using another data structure. How can we sort the frequencies of the elements in our array? We can do this with an array list. So let's go ahead and initialize a list. We'll use a for loop here, and we're going to add all of our frequencies from our hash map into our list. So we'll say list.add map.get I. This will insert our frequencies one at a time. Then we need to sort our array list so the order is least to greatest. Our hash map returns item at random, so sorting here is necessary. So let's go ahead and initialize a result variable to m.size. So after we had just sorted our array, m.size represents the amount of unique keys in our hash map. which in our first example would be 4. 4, 2, 1, and 3. This equals the initial size of the map, as we just said, which refers to the number of unique key values, in this case our unique elements that are in our map/array. So remember, we're given a value of k. This represents how many elements from the array, or appearances like we talked about previously, should be removed. Also, we no longer need to touch our hash map. We can merely work with the frequencies in our array list. We don't have to update the actual frequencies of the elements after removals in the map at all. So here's kind of the bread and butter of our solution, is this for loop here. So we're going to iterate through our sorted array list with a for loop, and for each element we encounter, starting from the least, going to the greatest, we'll subtract that frequency, which is I, from k. Now if k is less than 0, that means that we did not remove all of the appearances from that current frequency, okay? Because say k equals 1, so we only have one element left to remove. If the frequency of our least value is 2, and we subtract it, k equals -1, which we can't do. We can only remove k elements. So if k is less than 0, this means that we did not remove all appearances of the current least element. So there's no need to update our result variable in this case. We can just return our result. Now if we get past this, if this doesn't catch, we'll go ahead. That means that we could remove I, which again is a frequency of an element in our array. So if we can remove that total frequency without k being less than 0, we go ahead and update our result variable, just subtract by 1. That means we technically removed that element entirely because we were able to remove all of its appearances. And now we'll say if k equals 0, that means we removed exactly all occurrences of the last I frequency value. So we already decremented our res variable. We can just leave the for loop and return our answer. So we break. End for loop and return our result. So let's go ahead and code up a solution together. So remember to import your libraries here. This wildcard will cover your hash map. It will cover your array list. So we'll create our hash map first. Call m new hash map. We'll go ahead and initialize our array list as well. We're just going to call it L. Now we'll say for an I less than AR.length, I++. We're going to count our frequencies. So m.put, ARI, m.get or default, ARI, 0 plus 1 has to be outside the parentheses there. So that's going to create our map. Now we're going to fill our array list with the frequencies in our map. So we'll iterate through the key set of them. And typos left and right. We'll do l.add m.getI. So this is going to take that array value, right? Each unique number in our array, each unique key, and it's going to return the frequency. And then we'll just add that frequency with l.add. Now we'll go ahead and sort our array list because we need the least frequencies to show first. We'll establish our result variable with m.size. Now here's our main for loop. For integer I and L, we'll say k minus equals I. If k is less than 0, we return res. Now if we get past this, we'll decrement res, which means we removed all appearances of an element. So that's obviously going to subtract from the total number of unique integers left in our array. Now if k equals 0, we're able to remove that element exactly. And since k equals 0, we're done removing things. We're only doing k removals. We can break, and then we can just return res. So I think this looks good. Let's go ahead and run the code. And it's collections.sort. And as you can see, that worked very well. Let's go ahead and submit it. See if this can come out any faster. I don't know why it's so much slower than my last solution. Because my last solution is literally the same thing. I have a lot of things open on my computer. Maybe that's part of it. But so as you can see, we're about 50% faster. This same solution, though, got me this 51. So I don't know why it's so much slower today. But overall, there's many ways you can do this. I think this is a pretty intuitive solution with just 2 data structures and the hash map and the list. It's definitely a fun problem. It makes you think. And thank you very much for watching. I hope you enjoy the next one. Bye-bye.